Hi, we are going to see about CPU scheduling. In the CPU scheduling, we are going to see the second type, that is shortest job first scheduling. Shortest job first scheduling means from the given process we have to check which has the least time for taken for its execution. Thus, if there are 4 or 5 processes in it, we have to check which has the least burst time. That is, the process will be completed soon when compared to the other process. Likewise, these processes should be taken into execution in the ascending order. Okay, here that is the process execute based on its time taken. If there may be any process, if the least thing is taken first. Thus, in this example, there are 5 processes, each has some particular burst time, but the P5 has the least one. So here it means it has the shortest job and it should be taken first for its execution. Okay, then this is our non-preemptive CPU scheduling. Non-preemptive CPU scheduling means once any process is taken for execution, it should be completed, then only the second process should be taken. Before completion, no process has to be taken. It is stop and next process should be sent for execution. Here we need to find 3 things. First one is our NAT chart in the sense we have to write the process in which order it is going for execution and the waiting time and its completion time. So here when analyzing P1, P2, P3, these are the 5 processes and P5 has the least time taken for its execution. So here initially it starts with P5. Next thing is 2, which this is P4 process has in it. Next one is P2, which has 4. Next P3 and P1. Initially, this means that we are writing it as 1, 2, 4, 5 and 8. Yeah, it is in an ascending order. So initially if any waiting time is given, that is to be considered. Here no waiting time, so initially the waiting time will be 0. Next we have to check the P5's execution stage, that is 1, 2, 4, 5 and 8. So it's P5 has taken first because it has only 1 second for its execution. Then by completing its P5 process, the time will be 1 second. So after completing 1 second, that is P5 gets completed, then the next process which has the least time of execution is taken, that is P4. It takes 2 seconds. So 1 plus 2, that is 3 seconds. Totally 3 seconds has been completed. Next thing is P2 has 4 seconds. So it is 3 plus 4, 7. Our next process after P2 will be P3 because it has 5. So 7 plus 5, 12. And this is 20. So this is our NAT chart. This is the main thing we can. Next is we have to find the waiting time. Waiting time means each process waits for complete before going to its execution. So process are P1, P2, P3, P4 and P5. These are the 5 processes. So our waiting time is the time that it's wait before completion. So P1, where is our P1? Here. So the waiting time of P1 is 12 seconds. Next P2. P2's waiting time is 3 seconds. P3 waiting time is 7. For P4 1 and P5 0. But one more thing we have to consider, as I said, the waiting time of this is 0 here. In some situation there will be given some time. So if it is 0, then we have to minus it with the starting value. In some, as there may be some 1 second, 2 second like that. If so, we have to minus because the process starting time has to be noted. So here there is no like that. So the 12 minus 0, there is a this will be same 7 minus 0, 1 and 0. So this is our waiting time. This is because of here which from which timeline we have started. If suppose we have started it this at 5 seconds, from here only we in the place of 0 there will be 5. So that is main thing. Next we have to find the average waiting time. Average waiting time is sum of this waiting time minus the number of process. So the waiting time is 12 plus 3 plus 7 plus 1 plus 0. So we have 5 process in it. That is 23 by 5. So the value is 4.6. So the average waiting time for the shortest job is 4.6. Next we have to find turnaround time. Turnaround time is calculated nothing but our waiting time plus our burst time. Waiting time is found here and the burst time is here, which the process taken for completing its entire task. So the process will be as it is: P1, P2, P3, P4 and P5. So our turnaround time is waiting time plus burst time. So P1's burst waiting time is 12, P2 is 3, P3's waiting time is 7, 1 and 0. Then we have to add it with our burst time. That is, the process gets completed at P1 takes 8 seconds for completion. So plus 8. P2 takes 4. P3 takes 5. P4 takes 2 and P1 takes 1. So the value is 20, 12, 3 and 1. Here we have then, like before, we have to find our average turnaround time. So that is 20 plus 7 plus 12 plus 3 plus 1 divided by number of its process. So here is the only the 20 is extra, so it is 43 by 5, that is 8.6. Okay, so shortest job first, in the sense the least time taken for this process to complete is first considered and it is sent for execution. And the main thing is non-preemptive. On any situation the process does not get stopped. After completing only the next process is sent. Okay, here then the snapshot is found by the time depending upon the our burst time value, and the time waited is calculated. Initially if there is no time, 0 is considered, and 0 plus 1 for the entire process. P5 gets completed at 1 second and P4 get processed at 1 second and complete at 3 and so on. Here waiting time is calculated from this snapshot, that is P1 is waiting until 12 seconds for all other process gets completed, and minus our starting stage of our waiting time. So like that we have found for all 5 process and we have found the average waiting time. Similarly the turnaround time is our waiting time plus our burst time. But waiting time is found here and burst time will be given in the question itself, time taken for the process to get completed, and we have found average by sum of this turnaround time by its number of process, and it is 8.6. Okay, thank you.